everyone, this is Mrs. Hanson. This is Lesson 2-6, Nonlinear Inequalities, Video 2.6.1 and 2.6.2. Our learning target for this video will be for students to be able to solve a polynomial inequality. So, we are looking at solving a polynomial inequality, and in this example we're asked to solve x squared minus 8x plus 16 is less than or equal to 1. So, we have a quadratic on the left side of this inequality, right here, x squared minus 8x plus 16, and we have a 1 on the other side. And so just like when we're solving a quadratic equation, right, an equation has an equal sign, an inequality could be many different symbols. It could be greater than or equal to, less than or equal to, less than or greater than. Those are all examples of inequalities. And what we're going to do here is we are going to get all the terms on the same side of the inequality just like we would do in an equation. So the first thing I'm going to do is subtract 1 from both sides, and I get x squared less than 8x plus 15 is less than or equal to 0. Now, I could factor this polynomial here, factor this quadratic, and so that we have an opportunity to determine where the zeros of this quadratic function are. So if I factor x squared minus 8x plus 15, I'm looking for two numbers that multiply to be positive 15 and also add to be negative 8. And if I think about it, negative 5 and negative 3 are going to be the two numbers that when I multiply them together I get positive 15, but if I add negative 5 and negative 3, they give me a negative 8. So of course if I FOILed this out, I would get x squared minus 8x plus 15. Now what this tells me is that if x minus 5 is equal to 0, the 0 of this function is at positive 5. And if x minus 3 is equal to 0, I know that the 0 of this function is also at positive 3. So I have two zeros for this polynomial function, right? I know that we are going to cross at positive 3 and again at positive 5. Now, some other things that we could add to this graph is that because I could use the leading term test to determine what my end behavior is, and if I have a lead term of 1x squared, since this power is even and the coefficient is positive, we know that both ends are going to go up. So I know right now that this end behavior, both points up, and the end behavior for this function, both ends point up for this function, and we know that because our degree is 2, or our exponent is 2, we have one turning point. So I know that this graph is going to come down like this and have only one turning point, which is a minimum, an absolute minimum for the function. So we know what the graph looks like, and the question then becomes, where is this graph less than or equal to 0? In other words, where is our y-coordinate less than or equal to 0? Well, if I highlight that on the graph, the function is less than or equal to 0 right here when it's below the x-axis. So, and the function right here is actually equal to 0. The function is actually equal to 0 at 3 and at 5 because those are the zeros of our function. So when I represent the solutions here, there are several values of x which have a y-coordinate that is less than or equal to 0. And I've highlighted that entire piece of the graph right here in red where the graph of the function is less than or equal to 0. So when I write out my solution, since there's more than one x value where the graph is less than or equal to 0, I'm going to write it out as an interval. So the graph becomes equal to 0, the first spot it's equal to 0 is at 3, and I'm using a bracket around 3 because 3 is included, because of the inequality here, they want to know where the graph is less than or equal to 0, and the graph happens to be equal to 0 at 3. And it's going to, the last place the function is going to be less than or equal to 0 is at 5. And again, because the function is equal to 0 at 5, we're going to use a bracket around that value. So the function becomes less than or equal to 0. Our solution here is for any x value that is in between 3 and 5, that is where the graph of this polynomial is less than or equal to 0. All right, I want to check for understanding here. I want you to solve the inequality x squared minus 9x plus 10 is less than 46. And you have 4 choices, A, B, C, or D. So work out the inequality, choose your response, and press submit. Okay, so if we're going to solve this inequality, we have x squared minus 9x plus 10. I'm going to subtract 46 from both sides so that I get a 0 on one side. And I collect all the terms on the same side. So I get x squared minus 9x. If I combine 10 and negative 46, that gives me negative 36. And if I look at this quadratic trinomial, I can factor this so that I can find the zeros of that polynomial. So x squared minus 9x minus 36, I'm looking for 2 numbers that multiply to be negative 36, but also add to be negative 9. That is going to be x minus 12 and x plus 3. Negative 12 times positive 3 gives me negative 36, but when I add them, I get negative 9. My zeros then are at x equals 12 and x equals negative 3. If I set x minus 12 equal to 0, that gives me positive 12, and x plus 3 equal to 0 gives me a 0 at negative 3. Now, looking at the end behavior again, because my lead term is 1x squared, I know both ends go up. So when I sketch the graph here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, positive 12. And I have negative 3, 1, 2, 3. And I know both ends are going to go up. And because my highest power is 2, that means we can only have one turning point, which means the graph is going to go down like this. Now, this is just a sketch of the graph. Obviously, I didn't plot exact points on the y-axis. I didn't give exact y coordinates of every point. But what we're looking at is where the function is less than 0. So if I highlight that on my graph, I'm going to highlight where the graph is less than 0, which is right here. It's where the graph is below the x-axis or where the y-coordinates are less than 0. Now, one thing that's different in this example than the previous example is our inequality sign. Our inequality sign here is less than 0, not less than or equal to 0. So when I write out my solutions, I am not going to include negative 3 or positive 12 because at negative 3 the function is equal to 0 and at positive 12 the function is equal to 0. So therefore, because our inequality just states they want to know where the function is less than 0, not less than or equal to 0, when I write out my interval, I'm going to say negative 3 to positive 12 and use parentheses and not brackets because we don't want to include the zeros based on our inequality sign being less than 0, not less than or equal to 0. So if I look at my choices, A, B, C, or D, A is my solution, and we are done. All right, moving on, we're going to solve a polynomial inequality using the end behavior, which I kind of noted in the previous example. We also used the end behavior in the previous example. It says solve x cubed minus 22x is greater than 3x squared minus 24. So just like in previous examples, we're going to collect all the terms on the same side. So that means I'm going to subtract 3x squared and add 24 to both sides. And that gives me x cubed minus 3x squared minus 22x plus 24 is greater than 0. So this time I have a cubic polynomial because it's a degree 3 polynomial. And what we're going to do is we are going to graph this cubic polynomial and go ahead and determine where this polynomial is greater than 0. Before we graph on Desmos, one thing I can do is the fact that we have 1x cubed as our lead term, we can determine the end behavior of our polynomial. Since our exponent is odd and our lead coefficient is positive, that tells me, the fact that this is odd tells me the ends have to go in opposite directions. Because the lead coefficient is positive, that means the right end is going to go up and the left end is going to go down. Now, we could have 2 turning points, because remember the number of turning points is always 1 less than the highest power. So when I graph this, I should see that the right end goes up and the left end goes down, and it's possible that I have 2 turning points. Okay, so we have the graph of the function, and indeed our right end points up and our left end points down, and we have 2 turning points like we suspected. And if we're looking at this function, we want to know where the function is greater than 0. Where is our y-coordinate greater than 0? So our y-coordinate is greater than 0 when the graph is above the x-axis. So I'm just going to highlight all the pieces where the graph is greater than 0. And if you look at where I've highlighted, again, we are not including the zeros of this function in our solution because we want to know where the graph is greater than 0, not greater than or equal to 0. So if I describe the interval here by this blue shaded region, I'm going to say the graph is greater than 0 when x is not equal to -4, but just from -4, greater than -4, all the way to +1. When we reach an x value of +1, our y-coordinate is 0. So again, this is why I'm using a parenthesis rather than a bracket, because remember, we do not want to include -4 and +1 in our solution, because we're only looking to describe the x values where the y-coordinate is greater than 0. Now we have this other piece right here where the graph is greater than 0, and so we're going to use a union here and state that the graph is greater than 0 from 6 to infinity. From this point forward, the graph continues up infinitely. The end behavior is pointed up, so then the graph will never come back down and be less than 0. So our solution to this problem is -4 to 1 and union 6 to infinity. All right, it's time for you to check your understanding. You have this inequality here, 2x cubed plus 9x squared greater than or equal to -3x plus 4. And you have 4 choices. Now, some of the responses got cut off here, so I'm going to write in what the other intervals are. This should include -1 to 1/2, parenthesis, nope, bracket. Here we have -1 to 1/2 with parentheses. Here we have bracket 1/2 to infinity. And here we have 1/2 to infinity. So you have 4 choices, A, B, C, or D. I want you to go ahead and solve this inequality and select A, B, C, or D and press submit. Okay, looking at this function, we're going to go ahead and collect all terms on the same side. So I'm going to collect all the terms on the left side of the inequality. We have 2x cubed plus 9x squared. We're going to get a positive 3x and a -4 greater than or equal to 0. So I added 3x and I subtracted 4 to both sides. So that leaves me with 0 on the right side, and we want to know where this function here is greater than or equal to 0. Now before I go ahead and graph this function, because my lead term has an odd exponent and an positive lead coefficient, my right end is pointed up and my left end is pointed down. And again, there's 2 turning points that are going to be possible for this function. So I'm going to go ahead and graph this on Desmos, and then we can evaluate where the function is greater than or equal to 0. Okay, so looking at the graph of our function, we do have 2 turning points, one up here and one down here. So we have a relative max and a relative min. And indeed, our right end points up and our left end points down like we suspected using the leading term test. Now we want to determine where the function is greater than or equal to 0. So I will go ahead and highlight that on the graph. So it's greater than or equal to 0 when it's above the x-axis or on the x-axis. Okay, my highlighting got a little thick there. But basically we start right here at -4 and end at -1, and right here where our other 0 is to positive infinity. So if I write out my interval, if I want to describe the interval where the graph is greater than or equal to 0, I'm going to say it starts at -4, including -4, because our inequality sign says greater than or equal to 0. And I'll say it ends at -1, and since -1 is a 0, I also include that in my solution. And the last 0 here is at positive 1/2. So I'll say union, bracket 1/2, comma, and since the end behavior goes up infinitely here, the graph will never be below 0 again, or less than 0. So since the end behavior is infinite and the graph is going to continue being positive infinitely, I'm going to say 1/2, comma, infinity. So if I look at my choices, A, B, C, or D, it looks like C is the appropriate response. So I'm going to go ahead and select C.